Hello, everyone, and welcome back to the Math Puzzle Crash Course. I wanted to expand a little bit on a topic I haven't covered a lot just yet, but I want to get into some algebra. I've been doing a lot of order of operations type problems, and I want to, do a little bit with algebra here. So I've got a few fairly simple algebra problems that have some solutions, and even some that have no solution. So let's get started. Our very first problem that we're going to look at is 4y minus 8 equals 0. So let's isolate and try to solve for y. One easy way to start that would be to add 8 to both sides of the equation. So on our left side, if we add 8 to negative 8, it's going to cancel out. And on the right side, it's going to really be 0 plus 8. So now we're left with the following here. We've got 4y equals 8. So how can we simplify that further? Well, what we can do is to isolate y on the left, we can divide both sides of this equation by 4. So 8 divided by 4 would end up being 2, and on the left side, we should end up with just y. So when we do this, we have y equals 2. And to check our answer, we can replace the y in the original equation and see if we get an answer that makes sense. So yeah, 4 times 2, and in parentheses, we've got a 2 in parentheses, which implies multiplication. So 4 times 2 minus 8 is 0, right? 4 times 2 is 8. 8 minus 8 would be 0. Um, the second problem that I've got is a little more difficult, but it's not too bad. It's y squared minus 3y plus 2 equals 0. So, yeah, this problem follows the format of a quadratic equation. And you might ask, well, what is a quadratic equation? Well, it's an equation that can be written in this form. The form is ax squared plus bx plus c equals 0. And in general, a quadratic equation will have two roots, and they can be equal to each other. Um, some quadratic equations can be factored, and what that means is you can rewrite them. So, like if you have ax squared here plus bx plus c equals 0, that's a quadratic equation that's not factored, but you can factor it. It can be rewritten in this form here, where you have a times x minus x1, the quantity x minus x1, times the quantity of x minus x2. Now, what x1 and x2 are called, those are called the two roots of the equation, okay? So I know this may seem like a lot to start out with, but we also have this nice little thing here that someone figured out. If a quadratic equation cannot be easily factored, and there are, I guess, some that can't be easily factored, you can apply the well-known quadratic formula. So I'm not going to go into a whole lot more detail on quadratic equations, especially the factoring and so on. I am going to do an example, though, to solve this problem. But this particular problem can easily be factored into that form we just showed you, which is a times the quantity x minus x1 times the quantity of x minus x2. So we're lucky here. This one's fairly easy to factor. We know by looking at our equation and we also look at that form, a is equal to 1. Why is that? Well, y squared does not have a number or a coefficient in front of it, so 1 would be what it is because a times 1 is the same as a. So, we're looking at this form right here. But before we try to factor this equation, it might be useful to understand what it means to have a factored equation. Yeah, so here's another example here. This is not related to this particular quadratic equation that we're trying to solve at the top. But here's an example. X minus 2, the quantity x minus 2 multiplied by the quantity x plus 5 equals 0. That's also a quadratic equation, but the difference here is that this is a quadratic equation that's already factored. So we're going to look at this example before we jump back to the other one. So I apologize, but there's a reason for doing this. This factored equation is made up of two expressions that are multiplied together that are equal to 0. When we look at this quantity x minus 2 times the quantity x plus 5 equals 0, any value of x that makes x minus 2 or x plus 5 equals 0 makes the whole product equal to 0. So that's what we're trying to figure out here. This simply means that if some value of x makes x minus 2 equal to 0, well, then x minus 2 multiplied by x plus 5 equals 0, right? Because 0 times x plus 5, or 0 times the quantity x plus 5, still is going to equal 0. The same is true if some value of x makes x plus 5 equal 0. Then, in this case, x minus 2 multiplied by the quantity x plus 5 equals 0. Because in that case, you're going to have the quantity x minus 2 multiplied by 0 equals 0. So if that doesn't make sense, I mean, you can pause the video, reread that, and or always back up. But let's kind of work that through. Let's look at our first product here, which is we've got the quantity x minus 2. So let's see what values of x, if we have x minus 2 and we set that equal to 0, well, right away we can easily see that x must be 2, right? Now, if we look at our other expression here, basically the other product that we've got, well, not product, I'm sorry, but we look at the other expression, quantity x plus 5, if we set x plus 5 equal to 0 to solve for x, we're going to get x equals minus 5. So for our example of a factored quadratic equation above, there are two possible solutions for this equation. X could equal 2 or it could equal negative 5. Either value solves the product of the two expressions with 0 as the result, which is what we want, right? We're saying up here at this top, we're saying at the top that the quantity x minus 2 times x plus 5 is 0. We don't really care which one of these two expressions goes to 0. I mean, well, they can't both because x can only be negative 5 or x can only be 2. But if x is 2, well, it's going to make this expression 0. 0 times x plus 5 is 0, right? If x is minus 5, you put that in here, well, that's going to make this expression 0. 0 times quantity x minus 2 is 0. So for that factored equation, there's two solutions: x equals 2 or x equals minus 5. Um, and like here I just do a little bit more detail on that by putting in a 2. I substitute a 2 in here. Well, 2 minus 2 is what? 2 minus 2 is 0. 0 times the x plus 5, like I just was describing on the last page here. You're going to end up with 0. And again, we'll work this one through. We said one of our other solutions could be x equals minus 5. And if you substitute it in, minus 5 plus 5 in this expression turns that expression into 0 right here. 0 times the quantity x minus 2 equals 0. So those two solutions work out. We verified our equation and then the solutions. So to get back to what our original problem was here, this whole backstory on factored equations is to help us understand how to take a quadratic equation that is not factored, such as the one above here, and factor it. That's what we want to do. We're going to try to solve it by factoring it and see what our solutions are. So remember from before that the form of a quadratic equation is a times x squared plus bx plus c equals 0. Since we said the coefficient is a equals 1 in our problem, remember we have y squared, so a must be 1. We can use what is called the sum product pattern. So we'll get into that here. So keeping in mind again that the pattern is ax squared plus bx plus c equals 0, the sum product pattern should help us find two numbers, which we talked about before, this x, this subscript 1 and x subscript 2, that satisfy the following. So we take our quadratic equation, we should be able to factor it so that it looks something like this: x plus x1 times the quantity x plus x2. But we need to find this x1 and x2 such that, and this is where the sum product pattern comes in, where when we say sum product, the sum, we have to, these numbers that we find, they have to satisfy this: x1 plus x2 equals b, and then x1 times x2 must equal c. And the b and the c are coming from this form up here, right? So you see this bx, right? That's the form of a quadratic equation. Well, if we look up at our quadratic equation, we've got a 3 up here, right? So yeah, that's what that is. And then c is this c over here, right? With plus c. This is what we're talking about here. And the c up here would be 2. So let's work this one through. So we're looking for this x1 and x2 that basically satisfy this: x1 plus x2 equals 3, and x1 times x2 equals 2. This is the b and the c that we just talked about. So we must consider the different pairs of integers that might satisfy having a product of 2 and a sum of 3. So we can take a guess at it. It's a process of elimination. You kind of work some things out. One good way to attack this problem would be to find numbers that give us the product of 2, and then we could go back and eliminate the ones that do not give us the sum of 3. That's one way to approach it. Just figure out one side of it, and maybe figure out the product side, and then try to figure out which ones of those maybe give us the correct sum. But remember, we're trying to satisfy two conditions. We're trying to satisfy both conditions here. This x1 plus x2 is 3, and x1 times x2 equals 2. So one thing I could do here would be, there's really only a couple possibilities. This is a fairly easy quadratic equation. There's only a couple things here that really give us a product of 2. Basically, we could have 2 times 1 is 2, or we could have -2 times -1 is 2. And of course, you could flip those. You could have 1 times 2 is 2, and -1 times -2 is also 2. Um, but if we look at those, we also need to figure out, well, which of those pairs also gives us the sum of 3? Remember, we got to meet that second criteria. Well, that's pretty easy, right? If x1 is 2 and x2 is 1, that satisfies the sum product pattern for this problem. So, because why is that? Because 2 plus 1 is 3. Yeah, they could be reversed too. It could be 1 plus 2 is 3. So, I mean, technically, you could have x1 is 1 and x2 is 2. It doesn't matter. You're really, it's going to work out to be the same, and I can show you why here. But you can easily see from that, which of those pairs gives us that sum of 3. It's basically 2 plus 1 or 1 plus 2. Either one of those will equal 3. So it takes us all the way back to that factored quadratic equation form that we showed, and it's represented by this a times the quantity x minus x1 times the quantity x minus x2. So if we take a look at our factored quadratic equation, it's going to take this form here. It's going to be x minus 1 times the quantity x minus 2 equals 0. Or it could also be written quantity x minus 2 times the quantity x minus 1 equals 0. You're going to get the same thing. And why is that? Because a is 1, x1 is 1, x2 is 2, or, a is still 1, but x1 could be 2 and x2 could be 1. We're just flipping those around here. So it basically means that our factored quadratic equation will take one of those two forms. So that means our y squared minus 3y plus 2 can be written the same way here or here. So there's another way to represent it. So we used y as our variable instead of x. And like the example, some of the forms they use x as the variable. We're using y in our quadratic equation, our unfactored one. So our factored quadratic equation's, going to look like this. Quantity y minus 1 times the quantity y minus 2 is 0. And it could also be written the other way. It could be quantity y minus 2 times the quantity y minus 1. Either way would be right. And if we want to verify our factored quadratic equation, we can expand it back into the original unfactored form if we wanted to, which is really easy to do. You just take the quantity y minus 1 and multiply it by the quantity y minus 2. And what does that do for us? Well, if you do that, you can take y, which is here, times this quantity, so y times y minus 2 minus, and then we have 1, which is here we have 1, or minus 1 times y minus 2, this. So, yeah, when you multiply this back out, and that gives you, and if you solve all that, it's equal to y squared minus 2y minus y plus 2. And if you simplify this, it becomes y squared minus 3y plus 2, which is exactly what we started with. So that really verifies our factored form. So sometimes I like to, reverse it back in case I made a mistake. And so that really helps us. So after all of that, our two possible solutions are either y equals 1 or y equals 2, right? Our x1 and x2. So y equals 1 or y equals 2. And again, it's really easy to check that too. We can check it by replacing y in our unfactored equation, and solve it. And if we do that, we could say, well, if we're assuming y equals 1, 1 squared is still 1, minus 3 times 1 plus 2 is 0, right? So that gives us 1 minus 3, which is what? Minus 2. Minus 2 plus 2 is 0. And then over here, if we assume that y equals 2, well, we have 2 to the second power, or 2 squared. That's equal to 4. Minus 3 times 2, which is minus 6, plus 2, which is still just plus 2, right? Equals 0. So that gives us 4 minus 6 plus 2 equals 0. And is that right? Well, yeah, 4 minus 6 is negative 2. Negative 2 plus 2 will give us 0. So that verifies our two solutions. Um, Now, there's another way to go. Like sometimes if you have a difficult um, quadratic equation that's difficult to factor, or if you just don't feel like doing the factoring, you can use the quadratic formula, which is written in this form here. I'm not going to bother saying it, but this is the form. And I hope everyone's familiar with this. I don't know what your particular level is in school, but or you're an adult or whatever, but this is a square root formula. So we're going to take this is taking the square root of b squared minus 4ac. And the A, B, and C are coming out of our form for the quadratic equation. So in the example that we just had, we had A is 1, right? Remember we said we don't just assume, but there's a 1. 1 times y squared is the same as y squared. So A is 1. This would be our b. I don't have the form of the quadratic equation again, but b would be minus 3. C would be 2, right? So all you do is you plug those values into that quadratic equation and let's see what we get. And we should get two different solutions probably because we have this plus or minus here. That's basically saying we're going to have a plus solution, probably a negative solution, right? Or, well, we're going to have two different solutions. I shouldn't have said a positive solution and a negative solution. That's incorrect. But when you work that out, you're going to end up with, and again, this is the standard form x using x. We're actually using y. So just think of this as a. Let me just go ahead and do that. Right? Can I do that? Yeah. Let's do this live. We're going to get a pen up here. So instead of x, I should have probably just drawn this as a y, right? Just assume y equals this. So y could be 2 or y equals 1. And we get those two solutions because, we're doing the plus minus thing here. We're taking negative of negative 3 as plus 3. And then we're adding or subtracting. So yeah, you're going to get the solutions of y equals 2 or y equals 1 by doing the quadratic formula. And actually, I mean, in a lot of ways, I think the um, this quadratic formula here is a little bit easier to work with. At least I think it is. I always had a difficulty when I was in school just doing the factoring, and I guess I don't think I fully understood the sum product method. As I was reviewing, I was like, oh yeah, there's that method. I was just kind of like trial and error trying to come up with it, and I would get it, but I was a little clumsy with doing the factoring sometimes. So yeah, using that quadratic formula, we easily come up with y equals 2 or y equals 1. Those are the two possible solutions again. So now we're going to move on to another problem. I know we just did a couple here, but let's try this one. This is one that I saw in a Quora post, which I thought was pretty interesting, but well, we're going to do it anyway. This one's a little easier. Y plus 2 equals y. And a lot of you are probably already scratching your heads on this one, like, what the heck is that? Well, it's actually a trick question that I threw in here that has no solution. If you tried to subtract y from both sides of the equation, you'd be left with the following nonsense. You'd end up with 2 equals 0, right? Which makes no sense. So there is no solution. That's really an invalid equation. Here's another one that I've got. This one I also saw actually in the same Quora post, and I thought I'd go through and work it out. But it's y squared minus y plus 2 equals 0. So yeah, we look at that one, and on the surface, it looks like it might be a legitimate quadratic equation. So let's jump right into we won't worry about factoring, but let's jump right in and use the quadratic formula on this one and see what happens. Well, if we do that, let's go back and look. If we remember what that form was for the equation, our a will be a 1 again. Y, we've got what, a negative 1? Or not y, but I mean b would be negative 1. B is negative 1. That would be the coefficient in front of y. So there's our negative 1 for b. A was 1. What's c? Well, c would be this number over here. Taking it from our quadratic equation, c is 2. Oh yeah, here's the form. A good thing I put it here. Ax squared plus bx plus c equals 0. So again, that's the form. And we're using y, so don't try not to let that confuse you. But the a here is a 1, right? Again, b is negative 1. Here's b, and if you look at the form, bx, well, we don't have a number in front of this, but we do have a negative 1. I don't have to draw, I don't have to write out negative 1 times y. You just put a negative in front of the y. So it's implied. Again, that's implied. And the c equals 2. So if you plug in all these numbers like this and you work it through, let's see what happens here. You simplify it all out. You come down here, you've got 1 plus or minus, and then you've got 1 minus 8. Actually, looks like I'm missing a, I'm going to have to fire my reviewer, which happens to be me. But yeah, you're going to have the quantity 1 minus 8 in here. Well, what happens? If you know about square roots, 1 minus 8 is minus 7, right? Uh-oh, that's not good. Look at that, minus 7. The square root of a negative number is not a real number. So you're not going to end up with a real number answer to this. So what does that mean? Well, that means there's no solution for this equation. We don't have a solution to it. It's not, there is none. So yeah, that's really what I wanted to cover, just a few real simple algebra problems, and I wanted to touch on the ones that didn't have any solution to them. So I hope this has been helpful. I hope this helps trigger you to maybe do a little research, go look up some maybe some educational sites online if you're struggling with algebra, and hopefully this will help. And again, if you found this helpful, please like the videos and please subscribe if you find this helpful. If you find some of the other videos helpful, please consider subscribing, liking. Also, feel free to share these videos if you happen to look on some of these forums or you happen to like to look at puzzles online and you see some of these things. Feel free to share this information with others. That's the whole point of it, is to try to educate as many people as possible. And so hopefully this is helpful. And again, I look forward to seeing a lot of you in some of the following videos I have. And have a great day.